Hello, everybody. We are going to wrap up circles, but I just wanted to do a really quick review. If you have not written down formulas, if you have not written down an example of each of these different things, I would highly recommend that you write some of this down as I go through it, because I think that it will be very helpful as we go through the proficiency. So we're going to start with circumference. Okay, and remember that these are your two formulas, either 2 pi r if you're given a radius or diameter times pi if you're given a diameter. We're going to go through how to solve these two different types of problems. Remember, for what we're working on, we're basically going to use 3.14. So we're going to say 2 times 3.14 times r, or diameter times 3.14. So you should notice that this is a radius and that this is a diameter. So you know that you're using each of these different formulas. For the one with the radius, we would say 2 times 3.14 times 7. And when we do that, 2 times 3.14 times 7, we get 43.96 inches. And remember, it is necessary for you to be able to put your units behind there. If you're not putting your units, you're not going to get a correct answer. And then secondly, for the diameter one, it is literally just the diameter times pi. So the diameter was 12. 12 times 3.14 gets us to 37.68. And then again, centimeters. Okay, so you don't know which type of circumference problem you're going to get when it comes time for the test. It could be one that's a radius. It could be one that's a diameter. You need to know how to do both so that you are ready for that problem. Okay, we're also going to talk about what happens when we have to work backwards. Okay, when we're given a circumference and we have to work backwards to it. So let me pull this up again. Oh, for some reason, it's making me write lines. All right, so we're given the circumference. So this is C. We need R. And remember, our formula says 2 times 3.14 times R. We are going to replace C with that. So we are going to say 62.5 is equal to 2 times 3.14 times R. I am going to multiply 2 times 3.14 and get 6.28. I am going to divide. And R is going to be equal to 62.5 divided by 6.28, or 9.95. And this is in inches, so your radius should be in inches. Okay, so you're just going to use the formula to kind of undo until you solve for R. If you're unsure if you did it correctly, plug this back in, 2 times 3.14 times 9.95, and you had better get 62.5 if you did your work correctly. Sorry. Okay, so that is the working backwards. So now we're going to talk about arc length. Remember, the arc length uses our circumference formula, and the only difference is that we're multiplying it by the degree over 360. So we're going to talk about finding a major arc and finding a minor arc. Okay, so this very first one asks us to find a major arc, which means we are looking for this part of the circle. So what we need to do is we need to take 360 degrees and subtract out the smaller part of the circle, and we should find that 315 degrees is the major arc degree. So now it just becomes a matter of using our circumference formula, 2 times pi times the radius, and then multiplying by our new degree of 315, which is our major arc, over 360. And you should be able to do this all on the calculator if you use parentheses, okay? Make sure you're plugging in with a bunch of parentheses. And when you do that, you get 65.94. This one doesn't need units. I mean, I guess technically you could say units, but because it doesn't have a measure, you don't necessarily need one, okay? So then the second one is talking about the minor arc. And the minor arc in this case is going to be this part right here, smaller, the smaller part of it. So it's already given to us at 100. So we again would just use our circumference formula, 2 times 3 times pi times 100 over 360. Okay, the circumference times the degree over 360. And when I plug that in, I get 5.23. Okay, so if you know how to find the circumference, you definitely can find an arc length because you're just multiplying it by that piece of the circle. Okay. All right, next thing is going to be area. And remember, pi r squared. For area, you have to have a radius. So if you're given a diameter, you have to find the radius first. Okay, in this first one, we are given a radius. So we would say 18 squared times 3.14. And that gives us 1,117.36 centimeters squared. Okay, for this one, it gives us a diameter, so we have to cut it in half to know that the radius is going to be 5. And then we plug it into pi r squared. And to get this one, we would get 78.5, and again, square centimeters. So radius is straightforward, plug it in and solve, diameter divide by 2, and then plug it in and solve. And the last thing is sector area, which is using the area formula and using the chunk of the area or the chunk of the circle that it asks for. Okay, so area first, and then do angle divided by 360. So this first one asks us to find this area right here. So we're going to find the area, which is going to be 9 squared times pi, or r squared times pi. And now we're going to do 120 over 360 so that we can get that chunk of the circle. Again, if you are good at using your calculator, you should be able to do this all in one thing with a bunch of parentheses. And then you hit equal and you should get 84.78. And again, if you are not following along and making sure that your measurements end up like my measurements, I would highly recommend it so that you can see if you're plugging something in wrong. And then lastly would be this one. Again, we're looking for this part of the circle. We have our radius of 10, so pi r squared, and then 150 over 360 for that chunk of the circle. So again, I'm going to plug it into the calculator. 150 over 360, and I get 130.83. So this tells you that you need to be able to find the circumference with a radius or diameter, an arc length, or work backwards, an arc length with a major or a minor arc, area, and then sector area. That is what you're going to be seeing on this Unit 12 proficiency. If you're struggling with any of these formulas, please reach out to me so that we can work through this. And I hope you have a fantastic day.